I did the flexural test on materials, and the crit test for them too. Did you wonder how the infill pattern or the percentage of the infill affect the stiffness? Hi, welcome to Slow Engineering. I'm David. I wondered about infill patterns and percentage when slicing the models. How exactly to go with these settings to meet my purpose. So I decided to make some specimens to do some quick tests. Open a Cura slicer, you can find tons of infill patterns for you to choose. But which one is for strength application? I picked up 12 patterns to test. They are grid, lines, triangles, trihexagon, cubic, octet, quarter cubic, concentric, zigzag, cross 3D, and gyro. Each pattern also separates into 5 different infill percentage as 20%, 40%, 60%, 80%, and 100%. I printed 2 specimens in PLA for the same settings to get 120 specimens in total. Before I show the result, guess what patterns make the specimens stronger than the others? There are some patterns that look really similar. Would they have almost the same results? On the percentage part, do there have any sweet points on each pattern versus to learn percentage, or they are just a straight line on strength when increasing infill percentage? First, let's look at the grid pattern. The roll deflections seems okay with a straight line, but something weird. Look at the 40% infill line. It has higher slope than the 20% infill. I know it is weird, but all the tests are tested under the same equipment, and the lines looks pretty straight. So, if you know what caused this scenario, please leave a comment below. Except for the 40%, 60% to 100% seems reasonable by increasing their bending strength. Remember the lower line you have, the stiffer parts you get. Let's move on to the second one, lines. Still the same problem. The 40% is the least stiff. Others are reasonable. Higher infill percentage, higher strength. Next, triangles. This one looks more acceptable. 20% to 100% line up. The 40% is almost the same as the 60% infill. The trihexagon, still the same problem. If there are printing issues, they should not always appear on the same percentage of the infills. It will randomly cause problems, not the 40% infill all the time. The fifth one, cubic. This infill is what I use commonly because it's 3D cubic, but share the pressures more evenly in different directions. Well, that is my thought. The result seems okay. All 5 line up. The 40% and the 60% infill are almost aligned. The sixth, octet, still the same issue. The percentage seems to have less impact on their strength. The quarter cubic. The 100% infill seems like a big strength boost. Interesting. The concentric. This pattern I usually use on the support roof or bottom to separate the parts and the support structure. The 20% is way more weaker than the others. This one would be quite interesting. The zigzag. It seems to have almost the same infill pattern with the lines, but the strengths are totally different. The lines pattern has almost the least value of flexural modulus I calculate, but the zigzag pattern is one of the strongest patterns I got after calculating. The 10th, cross. Another pattern that doesn't have too much change on the infill percentage increase except the 100% infill. And the next one is cross 3D. The pattern changes its size to have more support in XY direction. The last one, the gyro. Most specimens suffer at 40% infill strength drop, and this is 2. But in general, this one shows more bending strength than other infill patterns. How did I get their flexural moduli? I use linear regressions to find their slopes and calculate the flexural moduli. The diagram shows all 12 infill patterns in 5 different infill percentage relative flexural moduli. I know it looks messy, but it is easier to compare in the diagram. The grid shares the same result as the tree hexagon. What a coincidence. Some of them have an obvious drop on the 40% infill. I can't find a reason why they occur only in the 40% infill. If you have any idea or source, please leave a comment below. I was trying to find some sweet points on infill percentage for less material. As a result, more infill provides more stiffness in general. So, it is hard to tell if they have sweet points on patterns or infill percentage. Thank you for watching this video to the end. I hope you got some information on the tests. If you got something, like, share this video and subscribe to this channel to follow more projects. Or consider becoming a Patreon member to support my work. See you next time.